Quiz 6 key. Here we go. Pi bond, Br2, polar protic solvent. So this is not a halogenation, this is going to be a halohydrin, which means we know, what do we know? We know the solvent is going to add to the more substituted carbon. We know the first step is going to have 3 arrows. We know that the bromine and the solvent are going to be trans to each other. So we know the regioselectivity and the stereospecificity. Regioselectivity, solvent adds to the more substituted carbon. Stereospecificity, the two things you add are going to be trans to each other. Now let's start. First step with any of these halogenation or halohydrins, 3 arrows, boom, pi bond reacts, breaks the bromine-bromine bond, bromine comes back around. Showing the syn addition here, this first step, the bromonium ion. Solvent comes in, lone pair, nothing happens to these carbons or this hydrogen. Does that SN2 like, breaks the carbon-bromine bond. You see that anti-relationship now, went for the more substituted carbon, regioselectivity. See the anti-relationship, stereospecificity. Last step is a deprotonation. You could use the solvent to deprotonate, or you could use Br-, it doesn't matter. So you deprotonate, draw your product. Now at this point you ask yourself, did I make an asymmetric center? If I did, I need to put plus an enantiomer. I added bromine to this carbon. It has an H, a methyl, and all this stuff. This is an asymmetric center. Added the nitrogen solvent. This carbon is also bonded to 4 different things, so that's an asymmetric center too. So I need to put plus an enantiomer, right? If you wanted to draw the enantiomer, it'd be with the bromine down and its nitrogen and all its carbons at the methyl and ethyl pointed up. That'd be its enantiomer. All right, second problem here, Br2, pi bond, no polar protic solvent, right? No OHs, NHs, SHs, or PHs, so this is just a halogenation. We're gonna add 2 bromines. So we're gonna have 2 bromines, they're gonna be the stereospecificity, they're gonna be trans to each other. We're going to know the regioselectivity is that the bromine that reacts in that SN2-like fashion is going to go for the more substituted carbon. So yeah, and then we'll look for enantiomers at the end. First step, 3 arrows, pi bond reacts, breaks the bromine-bromine bond. Bromine, front bromine lone pair, comes back, makes the 2 carbon-bromine bonds. The other bromine goes for the more substituted carbon, that's this one, that SN2-like. This reacts here, breaks the carbon-bromine bond. You can see the 2 bromines are now trans to each other. Regioselectivity, stereospecificity. Did we make an asymmetric center? Here we have the tert-butyl, the bromine, the H, and this. So this one is an asymmetric center. So we need to put plus an enantiomer for sure there. But this one is not. So we just still need to put plus an enantiomer because we made 1. We don't have to make 2. If we just make 1, we need to put plus an enantiomer. All right, for these last 3, these are really focusing on hydrogenation and ozonolysis. So this first one is a hydrogenation. So what do we know about hydrogenation? We add hydrogen, 2 hydrogens, and we add them in a syn fashion. So in this case, I just show them coming on here syn. It really doesn't matter because there's already a H here, but it's good to realize that this is a syn addition. They add cis. The 2 H's are cis. It could also be, they both also could be wedged too. For this one, the ozonolysis, you cut the pi bonds in half and you put carbonyls on either side. And so this would be 2 ketones. Really important to number your carbons here. 1, 2, 3, 4, 5, 6, right? Should have numbered these. 1, 2, 3, 4, 5, 6. I'm not naming it here. I'm not naming, but I'm just looking to see I haven't missed anything. For these ones, working backwards from an ozonolysis, if you are shown 2 and aldehydes and ketones, you take them together and you say, okay, these 2 carbons are going to be are going to be actually bonded in a pi bond. So here you see that carbon right there is this one is this one, and then it could be cis or trans. I drew the trans version, or the E version too, but it could be either or. Could have got to this. Either one would have been fine.